Hello and welcome to this section of the tutorial where we're going to start to learn about a technique of integration that's extremely important, extremely useful, and that's called integration by substitution. And honestly, I cannot stress how important it is because up until now we've learned kind of some cookie cutter techniques. We've learned how to do the polynomial integration, we've learned how to do some basic trigonometry integration. But those are sort of like compartmentalized to a certain form, right? A certain form of an integral. Integration by substitution can really be applied to a great many problems. So it's more of a technique than a specific form. All right, so what I'm going to do, I could talk on and on and on about what it is, but there's really just a couple things I want to say, and then we're just going to dive into a problem because it's easier to show you how to do it than to talk about it. Bottom line is, when you have a more complicated integral, you really want to use substitution if there's a way that you can take that integral and make it into a simpler integral. So you can have a complicated looking integral and then do a substitution into that integral that will make it and put it into a form that you already know how to integrate. All right, and then you can integrate and get the answer. So it's kind of like a little bit of like a magic trick. You can take the complicated integral, use a mathematical substitution to transform it into a simpler looking integral, something you know how to integrate, and then you get the answer and convert back into into final form. We'll show you how to do that. And the other thing I want you to keep in the back of your mind as we do this, when you do integration by substitution, it is always, almost always, going to involve some kind of cancellation of terms. Not always, but almost always. So let's kind of keep that in mind, and let's go and work our first problem. Again, I could talk about it all day long, but really, once you see it done, I think it'll be a lot easier to understand. What if you have the integral of the square root of 4x minus 5 dx. So if you look at that and I tell you how do you do that, you're not going to be able to use the techniques you know how to use. The reason is because it doesn't fall into one of our regular forms that we've already learned about. Now, if you were to take away the radical and just forget it was there, then you do know how to integrate 4x minus 5. So that part we know, right? And if you were to take away the inside and just put an x in there, it would be x to the 1/2. If you erase the middle part and put an x there, it would be x to the 1/2 power. You know how to integrate that. So separately, there are elements to this integral problem that you do know how to do. You do know how to integrate square roots because you know how to integrate x to the 1/2. And you do know how to integrate the middle part. But when you put the two things together, you don't know how to integrate that because that's a different form than what we've learned, right? So you have to start thinking about substitutions. So let me just show you and walk you through slowly how to do this the first time, and then you'll kind of get the hang of it. What we're going to do is we're going to kind of create a new variable. You're going to start using u quite a bit, so get used to it. U is just kind of tradition. So we're going to say u is equal to 4x minus 5. That means that right now this integral is integrating over x in terms of dx. We're basically going to transform this integral so that we're not integrating over x anymore, we're integrating over u, which is a new variable that we made up according to the substitution. So what we want to do is we want to go down here and we want to say we have square root, actually what I want to do before I do anything else is I want to say, let's do it this way, 4x minus 5 1/2 dx. This is kind of just rewriting the radical. That's what I always like to do. And then what we want to do is we want to make the substitution. So we want to say, since 4x minus 5 we've defined to be equal to u, it's u to the 1/2. Now, if we didn't do anything else, and forget about the rest of the problem, don't you think you